Welcome to FOB TV, the future of business. I'm your host, Kevin Benedict. I'm a futurist and lecturer here at TCS, and I want to welcome all of you to the show today. My guest is a good friend and colleague of mine here at TCS. His name is Michael Deittrick. Michael, thanks for joining us.
It's my pleasure, Kevin. Thank you for having me. I appreciate it.
Yeah, so, there's a handful of us that are in the futurist team, and we all come from different backgrounds. Michael brings with him so much experience, especially in the area of manufacturing. And we're focused in on that today. We're focused in on the topics of digital twins and autonomous operations and manufacturing, all this. So I wanted to bring him on the show today because he can teach us all a lot of different things. So Michael, where are you calling in from?
Calling from Detroit, Michigan. Well, nobody actually lives in Detroit. I live out in the suburbs.
Got it. What's the weather like today?
It is cold. It was 6 degrees this morning. It's creeped up to 14. We're having a balmy afternoon.
Oh my. I had a lot of coldness last week. This week, though, we're up into the 40s here in Boise, Idaho.
Oh, that's nice.
Yeah, the snow's melting off real fast. Hey, so one of the things that every morning we wake up and there's just like more news around Gen A. So I wanted to just start out, it's kind of our warm-up exercise,
Sure.
Michael, and just ask you, when you think back on your whole career,
Yeah.
have you ever seen a technology that emerges so fast and has such a huge impact on the world?
As far as speed, no. I mean, that's the key thing, right? We've seen the acceleration of many technologies as they release. You see new apps get released, new concepts get released, and every time they are, the uptake on them is faster and faster and faster, but nothing has blown up as fast as Gen AI. And the interesting thing is within AI itself, the different models and the different things that are coming out have uptake that is even faster than the ones previous to them. So it's an exponential transformation. And it's funny that the world's greatest invention, language, is the reason we have Gen AI today and driving this, because we taught it how to speak, how to think, how to communicate.
Isn't that an awesome concept?
It is. It's a massive concept, right?
Man, we here on the team, we poll regularly. We poll people on, does AI, is that going to have a bigger impact than fire or electricity? Who knows, but it's going to have a massive impact. That's for sure, isn't it?
It'll have an impact in some way, right? I mean, when you look at fire, the answer is nobody freezes to death anymore, right? And you can cook food, and so you have less disease, all those things. Gen AI will change us fundamentally in other ways, right? Probably allow us to progress faster. And let's hope we can keep pace with it when it comes to our proclivities to how we conduct ourselves as we advance faster and faster.
So tell us a little bit about your background, Michael.
So I spent most of my career consulting. I did have a small stint at Daimler Chrysler working as a direct contractor to them in the automotive manufacturing space, but most of it's been consulting, either as a developer and then technology consulting, and eventually, some level of management consulting before becoming executive at two companies, and then arriving at TCS.
Oh, that's awesome. So let's jump right into a discussion on the connected factories. Yeah. And really what I want to get to is, how do all these technologies work together? IoT and AI and autonomous systems and digital twins. And is the goal, in fact, to create a real-time self-optimizing manufacturing environment? Is that the end of this path?
It's interesting, right? Because just a few years ago, 2017, we were talking about Industry 4.0, right? It became a big thing. It was recognized globally, even though it was already occurring. It got its biggest recognition in 2017. And the interesting thing is because of the advent of Gen AI, we're now looking at Industry 4.5, right? Because we're going to move beyond predictive maintenance and things like that because of these technologies, the convergence of them, and how they'll actually transform the way we think about it. Predictive analytics used to be about taking data and information and then making decisions based on data science to figure out when I should replace a part or change out a machine or something like that when it came to manufacturing. Now we're talking about the ability to monitor them in real time simulate their operation, identify problems before they occur, and remediate them. And then using an intelligent AI to do that, right? The IoT devices are capturing real-time operational data. That real data is then consumed by AI, and then AI outputs synthetic information. By taking those two streams of information, embedding them in digital twins and running simulations and creating decision trees, or however we're going to do it, right? Those are things that are still coming. We're going to design and think about how those things might work. But that's what will change us from predictive to proactive, right? That's my view of it. Because I always think that humans will make decisions no matter what, because the interesting thing about AI is no matter how much information you feed it, it's always going to use what other instructions or how it's trained to do things. And we're always going to find things that it isn't trained to do. Human beings figure that out all the time. I was trained to do this in college, but when I went to work, I had to do different things. I had to think for myself. And that's where things go. I might be getting ahead of myself. We might talk about questions of human and AI later, but that's kind of the way I see it. These virtual models of digital twins actually become the brain trust, the ability to make decisions between the IoT devices and artificial intelligence, large language models, large action models, whatever we deem is the right direction to make that happen. And it's a foregone conclusion. It's just a question of time.
So moving from predictive to proactive, you talked to me about that offline a little bit, Michael. Let's dig into that. I think all of us are pretty much familiar with the idea of predictive maintenance. Fix things before they shut down your whole operations.
Yeah.
But you brought up the fact that that's one step, but you're really wanting to get to real-time proactive remediation. What did you mean by that?
Well, predictive maintenance is a great step forward, obviously, right? People are using it today to try and reduce downtime, some of the large costly effects of manufacturing. Anytime a manufacturing process goes down, whether that's in discrete or process manufacturing, there's lots of money being lost. There's a calculable way to look at it, right? And so every company knows how much money they're losing when they're not producing. And so predictive maintenance was to head that off. What proactive remediation will do, right, is rather than just predicting, because we all know, that predicting anything is very difficult to do, even if you have tons of data. The reality is there are all sorts of variations in how things could or could not emerge. But what proactive will do is we're using real-time data along with the historical data to make better decisions about predicting when a machine should be replaced, maintenance, a part changed, all the way down to the part level, when the oil should be changed, how long can I make that machine last longer than it was originally created for, right? And that all comes from proactivity. Proactivity is the act of disrupting the need to predict. That's the beauty of it, because now I'm actually collecting and knowing and doing that information. I think the key shift is that when we actively prevent these downtimes, right? That's the key thing. The active prevention, not just the prediction of it happening, but the active prevention of it. That is when you'll start to see real value and trust in the manufacturing space that you can create more autonomy in the production of goods, right? And that is when we'll start to see more uptick and build an investment in this proactive space. I think everybody believes it can be done. I think that there's a little hesitancy. Should I spend a ton of money on this today to do this? So a lot of what's going on today is predictive. They're focused on that. Yeah. They know how that works. So they feel safe in that space. But we're going to see leaps and bounds and changes into this proactive space as we go forward. There's many benefits to it beyond what I could cover today. But just minimizing disruptions, costs, and extending lifespan of equipment is massive to any manufacturer.
So kind of in the same vein of thought there, you had brought up the notion of digital physical loop, a continuous feedback system. Talk to us about what you mean there and what's the benefit there.
I think the reason I always talk about this continuous feedback system, because a lot of people think, well, we're just going to train it to do this. We're going to train the system, to do things the way we've always done them. Right. But what we really want to have happen is we will train it to do that. We will make it proactive. We will have it start remediating. But we want that closed loop system to also not just make decisions about what might happen, how to fix parts, but also optimizing the process. Saying, what if we did this? Get the machines the ability to actually analyze inside that closed loop where you might find better efficiencies in the actual process of manufacturing, whatever it is you are manufacturing, whether that's process or discrete manufacturing, developing a product or a like petroleum, right? They're two distinct manufacturing products. They're different, but they all benefit from the same concept of how do I improve efficiency? Because that all comes down to how well will I perform as a company going forward. It'll also allow them to start looking at ways that they can move away from traditional manufacturing. Think about that for a minute. So if you have this closed loop system, you start looking at these new ways of doing things like additive manufacturing, doing 3D printing, or you might even move into atomic and molecular design. The answer there is why do I do this anymore? This doesn't make any sense. We now have this capability. So, but taking the best things, the things we know about how to make that part the best, the strongest, and everything, and transposing those into a new manufacturing medium is also valuable in that context.
So we talk a lot about digital twins, Michael, and the role they play. And, in some of the first iterations, you would have Internet of Things environment where you would have a sensor you would place on an object, a machine or something that would capture data. Then using telemetry, it would send that data to you and sits in a database. And then at some point you would do analytics on it and try to see patterns that would then help you do something better. Today, we're talking about real-time and AI-driven real-time decision-making. What role do you see digital twins playing in that process now?
So it actually injects true intelligence into the process. So before I jump into that, I'd like to actually talk about the fact that we've inverted the concept of being smart and intelligent. Smart, used to mean, or it does in normal nomenclature, that I'm good at making decisions, right? And intelligence is the concept of pattern recognition and knowledge, right? We've inverted that. We've gone and said intelligence is about making decisions and things, and smart devices are about collecting data, right? There's an inversion in the AI world, right? Where those definitions don't mean the same thing today that they meant yesterday. And whatever reason that occurred is irrelevant. The point is understanding the difference between the two is important when you talk about using data in real time. And why are digital twins important? Because in order to make something smart, it has to be aware of what's going on now, not what happened yesterday or the week before. If we look at human intelligence and human smarts, right, we use our experience, which is the data we've collected, and what we're observing now to make better decisions. What digital twins allow for in the concept of collecting the data and the telemetry and the information from sensors in real time, along with historical data, allows them to make smarter decisions, better, more informed, intelligent decisions. However you want to use those two words, as we discussed, the reality is that's the goal. The goal is to give them we talk about artificial general intelligence as being truly intelligent, but when it comes to this process, the act of making decisions and the act of knowing something have to combine in order to truly create real automation in the manufacturing space.
And you used the term the nervous system of manufacturing, I think, last time we talked.
Right.
When you look at all this is like a nervous system. So how does the integration of these technologies enhance things like quality control and defect detection?
So there are so many different applications that make that happen, right? Yeah. So we could go to final the final section of a manufacturing plant, whatever it is, and we look at quality control before it rolls out the door and gets shipped to somebody. The reality is that we could use computer vision to look for defects, right, in the product before it goes out. But you could all the way back to the beginning where you're sourcing materials, and do I have all the materials to produce everything that's on the docket today? And from the late 90s till now, we've done that in so many different ways, right? We've emerged discrete manufacturing into flexible manufacturing. There's been this constant evolution of how manufacturing is done. And many of these companies incorporate all these different types within discrete, right? So if we stick with just discrete manufacturing, the concept there is I have parts, I make the parts. That's a manufacturing process. Then the parts come and they have to be assembled. So there's a process to all of this, right? And that's literally, at the end of the day, all those parts coming together and create a product. It depends on the manufacturing processes being seamless and working from place to place. And there are many different technologies. Well, all those technologies are difficult to manage because of the ability of a human being to communicate with another human being. My system is about to fail. But everybody down the line is like, well, I still have these parts. I'm going to keep making parts. Problem is that's where the breakdown in the manufacturing process starts, is the inability to see the whole picture. And what artificial intelligence and digital twins and everything allow us to do is to create tiering, right? We have layers of abstraction that allow us to look at everything from that perspective. And we can see things possibly before they happen or as they're happening and recommend remediation as a whole, right? Across the entire, so basically healing the entire process and looking at it as whole, rather than I've got to get this section of my plant up and running again, right? Because it's holding up the other parts. So if we look at the whole entire process in that way, and that can extend all the way back to supply chain, that's the beauty of this. We don't just talk about making parts or anything else. We could talk all the way back to raw material resources required in order to do this. It allows us to make far better decisions across the entire process of concept to, sitting in someone's driveway as a vehicle, or the iPhone you have in your hand, right? Or in some cases, the petroleum you put in that car, right? So that's the thing. That's what I mean when I talk about this large nervous system, is we don't look at the whole thing. We might look at, why is my, it's in human context, why is my toe twitching? Well, that's actually something in your spine, right? We know that medically. It's the same thing when you look at the manufacturing process.
Wow. So, this sounds so powerful. And, to imagine some part of your operation where it has 100% visibility, it can anticipate things because it can recognize patterns, it can reach outside of itself to find answers. All of this makes me wonder, what role is there left for humans in this process? Are humans just to deal with exceptions and problems? Or is there a role of humans in the middle of these manufacturing processes?
This is always my favorite question, because this comes up with anything you talk about AI or any type of automation. Time immemorial, right? We've been dealing with these. How are we? Is a machine going to replace a human? Now, is this intelligence going to replace it? I think the reality is there are high stakes decisions, right? That you're not going to be able to trust to today's version of AI, maybe tomorrow's, right? And we don't know that yet. But that's the beauty of invention. We don't know what's going to happen. We can imagine the future and what that might look like, and it'll probably happen. But I think when we think about it into concept of today, the reality is that humans are always going to need to be made high stake decisions, right? Because there will be, the one thing an AI can't do, even with digital twins and IoT and everything, is experience the world. It doesn't have context. That's what's missing. Human beings can bring context to situations and problem solving. I think an AI becomes very, very helpful as an assistant to those high stake decisions, right? Because we all know humans make bad decisions too, right? We don't always make the right decision. So I think when you put the two together with those high stakes areas and adding context, that's what humans bring. I think there's a symbiosis that will emerge between humans and AI over time. Whatever AI becomes eventually, what we all dream it might be, those things might change subtly over time. I think the biggest fear is that AI will become more intelligent than us, then how will we know? That's an interesting question, right? It's like, if it's more intelligent than me, how would I know? Because I couldn't tell it it's wrong because it knows something I don't know, right? And so you get into those things, but that'll get you twisted around the axle, right? The reality is that I think that's where humans play, right? And so AI is really, in my opinion, a fantastic advisor. And this is the type of advisor where you're not saying, can you tell me from your experience? It'll actually take what it knows, what it's observed, and make the best recommendations possible. And you as a human with context can tell whether or not that's actually good data or not good data. Because the other thing that AI can do is be wrong, right? Yep. Because it can't see what's going on. It's not visually there. And this is where we could get into talking about embodied AI, right? And things like that, and get really crazy and talk about that could change the world. Now we have visual robots that see and experience what's going on around them. They can see what's going on and create more context in that space. But that's for another podcast, I guess. Right? It's another discussion.
But let's dip our foot a little bit in the risk.
Right.
So the more we turn over these decision-making assignments to AI, there's also risk. We might become over-reliant on AI, and
Yes.
there's vulnerabilities built into AI. So talk to me about where you see the risk potential.
Well, the risk of AI, of any automation, not just AI. The risk of any automation is that it doesn't produce exactly what you envisioned, right?
Mm.
And that's always the question, right? So that's why we go through the process of testing, understanding, how repeatable is it? How crucial is that decision? The risk is mitigated by taking that approach. If we just start saying, well, it knows how to make decisions, let it start making decisions, what will happen is we'll end up with an AI that makes decisions that make the whole system break down. Then it starts making decisions on its previous decisions, right?
Yeah.
And it becomes this cascade of failures. And
Mm.
that's the biggest risk, right? Is that humans will stop something. We will go and say, stop doing that. We obviously made a bad decision. AI is constantly being fed data, and it might not recognize that its first decision created the cascade of failures. We don't know if it can or cannot do that, right? So that's one of the things we need to focus on, is understanding that, because reasoning is something that's difficult. It's funny, I was having a conversation just today where I said, AI always agrees with me. I'll be typing into an LLM and I'm like, what do you think about this? It's like, oh, that's a great idea, right? And it's interesting how that works, right? Because AI is trying to capture your attention too. It wants you to engage with it. So it's already been trained with certain biases and things like that. So it wants you to engage with it. I mean, that's really the goal. That if you're a creator of an AI, an LLM, you want people to engage with it. So of course you're not going to have it go and say, you're a dummy. So, right. So the answer is that we have to weed out these biases. That's the other risk. We have to weed out the biases, right? Because when it comes to manufacturing a part, at the end of the day, we shouldn't care as long as it's quality. We're getting the quality, the expectation, and it's all coming out. So if that can be consistent, then we've mitigated the risk enough for AI to manage that piece, right? But if there's too much nuance, too much change, too many opportunities for cascading failures, then we probably don't do that. But that allows. But there's a middle ground for this. The middle ground is to allow the AI to do that, but not allow it to execute it without human intervention. So the answer is we don't have to do one or the other. We can create gradients of engagement, and that is really the secret, I think, to moving forward with this. And then as you create those gradients, that becomes those points that you look at for automation as AI takes over more and more of that gradient. That's the way you would look at it.
So let's focus 10 years ahead, and we'll squeeze on our futurist hat for this particular discussion. Let's talk about the nature of manufacturing.
Yeah, sure.
How might the idea of a manufacturing plant change when it can all be digitalized, AI driven, and automated? Lights out manufacturing, right?
Yeah.
It just, whatever orders come in, it produces and kicks them out the shipping gate, and they're sent off to the customer.
And there are robots who pick it up, inspect it, set it everywhere, right? You'll have robot trucks pretty soon, right? Yeah, exactly.
So how will the nature of manufacturing change? Will these become bigger plants, smaller plants? Will they be lean supply chains spread all over the globe, or will they be relocalized because the same building, the same robots, the same systems can create a complete different product in the afternoon than it made in the morning because it's just all code?
Yeah, that's a great question. And the reality is let's look at manufacturing alone, what it is, right? Today, the essence of manufacturing is mostly subtractive, right? We extract minerals, we build pieces, then we extract pieces off of them, we put it all together, right? And so a majority of that. And then we have formative manufacturing where we're actually pressing things and making them form the way we want to, and we're forcing that, right? And we use tolerances to do that, fixtures to make sure they're right, all those things. A lot of that's being digitized today. So there's a lot of information around that. But what's most important is when we start looking at additive manufacturing, the ability to 3D print, or going into 5D and 6D, where we're talking about atomic and molecular structuring, right, in both bio and synthetic and nanotechnology, starting 10 years from now. I don't think that's out of the realm of possibility. Those are things we will see, mostly because AI will help us advance that fast. That's the other beauty of it, right? It'll help us advance much faster. And we'll start to see those things. And then it just becomes a regulatory question, right? So But
just because you can make a head, should you make a head?
Right, exactly. So, but you get into but ignoring the regulatory issues, right, that we know will come up as we go forward. The point is that there are relevancies to micro factories, or, imagine a warehouse is no longer a warehouse. It's now converted into a manufacturing center that 3D prints everything on demand. And the other beautiful thing about this is I know everybody like global. So you're still going to have global resources. You're still going to have raw materials, things like that are globalized. When we start talking about making things for a region, regional manufacturing is going to make much more sense. It's going to be better for the environment. It's going to be more culturally relevant. That's the other beauty of it, right? The region will benefit by having its own influences over why it's made the way it is, why it makes sense. There'll be less issues with dealing with cross-border regulations. So you're going to start seeing it. So
maybe even tariffs and stuff.
Right. All that starts to go away. It's interesting, right? But that also creates self-sufficient sovereign nations. Now the question is whether the world's headed towards more sovereignty, less sovereignty. That's irrelevant. The point is that there is going to be localization that will occur, right? It's simply because these massive plants, they're sitting everywhere. The answer is it costs a lot of money also to move things, right? Yeah. The only way you can make things cheaper, if it has to be traveled further, is to make the labor cheaper or to make something else cheaper. And the answer is that for humanity to move forward, the reality is that if the more we can localize things, the more culturally relevant things become, and the less we waste. This is the other thing: the less we waste, then the better off we all are. And so I think both culturally, socially, economically, and technologically, there is no more logical reality than that is exactly what will occur. The question is how much of it will, right? Will it start in textiles? Will it start in vehicles? Will it start with, where will it start? And the answer is it'll be simple forms. We're already seeing that, right? Simple form, additive manufacturing, but with more complex forms where we're using different types of materials and being able to create those. And then the ability to actually create things within something else and have it unfold and shape to whatever it's inside of atomically and molecularly. All those things will change. Those will all drive, and then social pressures will also drive that as well. So we're going to see a lot of that happen. I think large manufacturing plants will exist 10 years from now. I just think that there'll be more micro manufacturing. And then you'll start to see the death of larger manufacturing as the ability to create more in those micro factories. And you'll start seeing less storage, less containers, less warehouses. It's gonna be an interesting world 10 years from now. I really believe that.
Michael, I want to thank you so much for taking time out of your busy morning to join us and share your expertise.
It's my pleasure, Kevin. Thanks a lot for having me. I appreciate it.